Okay, so here's you guys' video example for today. So we're kind of changing directions a little bit, and we're getting back into thinking about the Pythagorean theorem and similarity, but we are going to still be including or finding side lengths that have radicals involved, and so that's kind of why we revisited that over those last couple lessons. So again, we're looking at similarity in the Pythagorean theorem to help us kind of find unknown side lengths of right triangles, and then we're going to apply some of these ratios and see if we can come to some conclusions and noticings. So when I look at this first example, it says an equilateral triangle has a side length of 2 and angle measures of 60 as shown. Well, one thing that I know right away, if this is an equilateral triangle, it's not shown, but I know that this base also has to be 2, because equilateral implies that, or that's a fact, that it has all the same side lengths. So the altitude from one vertex to the opposite divides the triangle into 2 right triangles. So we know that's what the altitude does in this case, and that's kind of shown by the fact that this is the perpendicular bisector, and that's really what an altitude is in this case, so we know that this is also. So that kind of leads me to know that if this is the perpendicular bisector, and that's what an altitude really tells us, then we know that this has to be 1, this piece from there to there, if you want to think of it, and this also has to be 1. So if I'm just going to write that really quick, I can replace that 2 with 1 and 1, because I know that that's what those side lengths have to be. So the first question asked me to explain how I know these triangles are congruent. Well, I know that we have, for one, I have side, angle, side present in both of these triangles, which is one of our congruence criteria that we learned about previously in the year. So I'm just going to write side, angle, side, and I know that's true, and I'm kind of just shown that, and I'll put little stars in red as the criteria that I'm using to prove congruence of these two triangles. Okay, so that's my verbal explanation. I also know that if I have a 90 degree angle here is where I'm at, and a 60, let me see if I can zoom in a little bit for you. Hopefully that helps. So if I have a 60 and a 90, I know that this angle has to be 30 degrees. And I hope you guys are with me there, because if I have 180 degrees due to triangle sum, I know that that must be 30. Okay, so it asks what is the length of the shorter leg of each of the right triangles. I think I already filled that in. That's 1. And I kind of proved why I knew that, because the altitude stated in the question. And then let's use the Pythagorean theorem to determine the length of the altitude. So that's really asking for the other leg. Well, if I know that the hypotenuse would be 2, so 2 squared plus, and we could call it x if we want, so 2 squared plus x squared equals 1 squared. So that's kind of what we have. So I can continue to solve from here. I think most of you guys are probably comfortable with this. We could do 2 squared minus 1 squared. So if I rewrote this equation, let me just scroll up a little bit and zoom in. So I could rewrite this as 2 squared minus 1 squared, which is really 2 squared is 4, 1 squared is 1. So that really leaves me with 3. So I know that x squared equals 3, so I would need to square root both sides. So I know that x equals the square root of 3. So that would be my length of the altitude. That's kind of my answer for that part of that question. X equals the square root of 3. Okay, so that's kind of a big idea from this lesson. So I can kind of keep going. Hopefully I'm not messing you guys up by moving around. And I just thought I'd put the lesson on this video, so I thought I could just kind of show you what you're hopefully looking at in front of you. So continuing on, it starts to talk about these special triangles, or these certain types of right triangles, and the two that they really focus on are a 30, 60, 90, and then later on we have the 45, 45, 90. So it asks, if it has a hypotenuse of length 16, what are the lengths of the legs? Okay. So if I want to think about that question a little bit, am I running out of space? So I think I'll just do this one, and then I'll set you guys loose a little bit. So if I'm thinking about this question, okay, so what I really need to think about, I guess, when I'm considering this problem, and it kind of gives you some information. So notice that we have this short leg is a factor of 2 in comparison to the hypotenuse. and then we know that the longer leg is a scale factor of the square root of 3 compared to the short leg. So when I'm thinking about that, I know I can set up some ratios because I know that there's similarity present. Or it's asking me, will it be similar? But if we know that it has these factors, let's compare them. So if I know that the hypotenuse, which it tells me, has a length of 16, I really know that A, and if we want to call A the shorter length, so I'm using A as my variable for the short leg, I know that that has to really equal the ratio of 1 over 2 because it gives me the scale factor of 2. So if I have to multiply by a factor of 2 to get from the short leg to hypotenuse, that means the short leg is a half. So I think you can already tell from this proportion, but using cross products, I know in this case A would have to equal 8. So I know my short leg A has to have a length of 8. And I know that based off the 30, 60, 90 and the hypotenuse of 16 given the scale factor of 2. So I could do that same thing to figure out the longer leg back to the short leg. So if I know that we have B, and let me just erase this so I have a little more space and I'm on the same question. So in this case I'm looking for B, the longer leg. So if I have B and I could put that over 16, I can write my ratio in this case as the square root of 3 because I know that's how it compares. And then I can compare that to 2. Okay? Because that was really that scale factor of 2, so I'm comparing the square root of 3, and then we know that that 16 was double that. So I can solve this proportion now, so I can cross multiply, and when I do that and cross multiply, I end up with 2b equals 16 times the square root of 3, okay? And, which really tells me if I divide both sides by 2, 16 divided by 2 is 8, so I'm left with b equals 8 times the square root of 3. Okay? And that really kind of makes sense if I relate that to my smaller side length of 8. So if I know the scale factor from here to there was square root of 3, then I can really I could have maybe connected that, oh, it would be 8 times the square root of 3 in this case, because that's the relationship of that proportionality. Okay, so hopefully those two examples really help get you guys started, and I'll say good luck.